Welcome to HSG. Today we're going to talk about nuclear fission and atomic bomb. We all know that an atomic bomb has incredible power, but what exactly gives the atomic bomb such immense power? The answer lies in its name, atom. In 1938, German chemist Otto Hahn used neutrons as cannonballs to bombard the atomic nucleus of uranium, discovering that it unexpectedly split into two new nuclei. Inspired by cellular division, this process was named nuclear fission. The uranium nuclear fission not only produced new elements, but it also released tremendous energy. Physicist Lise Meitner calculated this energy and found that along with the reduction in mass after atomic nucleus splits, precisely adhered to the principles of Einstein's mass energy equation, E equals mc squared. The energy that originally existed only in theory thus became a reality. However, relying solely on one fission isn't sufficient enough. It wasn't until scientists Joliot Curie and Fermi, along with other scientists, discovered that uranium nuclear fission produced 2 to 3 secondary neutrons, which could continue to trigger nuclear fission, enabling the reaction to proceed automatically and became a chain reaction. This signified that with enough raw materials, unimaginable energy could be generated. Therefore, the final piece of the theoretical puzzle for the development of atomic energy was completed. In a chain reaction, if the number of remaining neutrons after each fission is exactly 1, the reaction will continue steadily, reaching a state known as the critical state. The amount of nuclear material required for this state is called the critical mass. Only with a mass greater than the critical mass can an explosion be initiated. In 1942, physicist Fermi achieved the first controlled chain reaction in human history. He used the element uranium-235 as the raw material. However, as the only nuclide in nature that readily undergoes nuclear fission, uranium-235 comprises only about 0.72% of natural uranium. Consequently, theoretically, they only needed 260 grams of pure uranium-235 to reach critical state, but in reality, it required a whopping 52 tons of nuclear fuel in the experimental setup. Clearly, such a quantity was far from meeting the requirements for a weapon. To create an atomic bomb, the purity of uranium-235 needed to be above 90%. Thus, the Manhattan Project spent over $2 billion and mobilizing over 600,000 people. Eventually, it successfully developed 3 atomic bombs.